So this is designing APIs, the other user interface. And I call it that because, to me, an API is a user interface. And we'll get into the details on that. But before we do, as I said, this is the last day, right? It's the last session. And you've had a lot of things to do. You're probably kind of tired. So before we get started, I thought we'd just do something a little bit different. I'm going to spell a word, and I'd like you to say it out loud. Really? Very easy, right? So like C-A-T, cat, right? And D-O-G is dog. Okay, so this is a longer word, and you're going to learn something about how your brain works with this. M-A-C-D-O-N-A-L-D. McDonald, right? M-A-C-I-N-T-O-S-H. Macintosh, right? So we got those two. Hard one. M-A-C-H-I-N-E-S. Wow. Most people I've done this with go Mac Hines, because it's Mac this, Mac that, Mac Hines. But you guys were great. So I guess you're more awake than I expected, which means this is going to be a more difficult talk. So traditionally, once you've done the slide, and the next thing is, who am I? You get the credentials. And that doesn't really matter here, except I want to say, Java 1, I've spoken there several times, and I actually did get Rockstar one year. I think it was because they didn't have a lot of, it was after Oracle bought them, and so a lot of the big names didn't show up that year. But yeah, so first thing, most important thing on this is you are an API designer, okay? And if you're a Java developer in here, it doesn't really matter whether you think you are or not, but you are, and we'll talk about why. So APIs, right? Application Programming Interface, there's all this stuff about what they are. For the purposes of this, an API is a set of services, right? It does something. Protocols for calling the services, and then the tools for using that. That's an API, right? And it describes what you have. You get functions, something it does, the service, your inputs, your outputs. The Wikipedia thing says the underlying types too, but I disagree with that because to me that's the implementation, and you should never ever let the implementation leak out through your API, right? And the definition is independent of the implementation, right? So don't talk about the underlying types, that lets them change. And the last thing is that programmers use APIs to write stuff, right? So it's prepackaged functionality that you can use. When we hear that, we think about things like systems and frameworks and libraries, right? But stuff like this. Google Books API, which is a nice public one, has docs and examples. Those are the tools. The base URL is here, and I left that up there because if you actually try to use that, if I try to put it on the slide, you never be able to read the bottom ones. But it starts off with books and then a version number. So you know books is what API because they have a lot of different ones. Version number there, and then they have a thing called volumes, which returns information about a group of books, right? You can put volume ID at the end to get information about a specific book. You can also then, they support the other concept is bookshelves, and you can have a collection of bookshelves, which is my library. You can ask for a specific one, and then from the shelf you can get specific volumes in a book off of that, right? So this is what we think of as an API. But what about a class? A Java class. Is that an API? Anybody?
Methods.
You're awake, I know you're out there. Yeah, methods, right, yeah. So an API is an interface used to access services, right? So you've got the public methods, that's an interface, right? You've got JavaDoc and sample code, you write sample code for your classes, right? And that tells the programmer how to use your API. Right? Now sometimes the sample code is actual sample stuff like in a tutorial, and sometimes the sample code can be your automated tests, your JUnit tests, right? In fact, those to me are the very best docs you can have for an API because they're always in sync, right? Because if they're not in sync, your tests are breaking. And it shows somebody how to use the code, how to use it properly, and what kind of bad things to expect. You know, it'll throw this exception or throw that exception. And speaking of throwing exceptions, right, I said, don't let the implementation leak out of your API. If you throw a SQL exception, guess what? I know you're using SQL, right? And now you're tied to that. You can't use something else because, or then you're going to throw a SQL exception from a NoSQL database. No, don't do it. Create your own exceptions. Okay, so be very careful about that, because once a class becomes published, once a class becomes public, somebody else is using it, you now have a public API, and you have the same problem Sun has, which is it's out there, and if I change it, I'm going to break somebody's code. Right? So because of all this, I say that the act of creating a class is creating an API, which makes you an API designer. So you can put that on your resume. It may not mean a whole lot to some people, but it may. You never know. So next thing is, APIs are user interfaces. So just like you do with any other user interface, you want to think about what your users are trying to accomplish. What's their goal, right? Why are they using this in the first place? And sometimes when, right? Now, for most of us, when we think of user interfaces, we think about computer screens with GUIs or maybe character-based interfaces, that kind of thing. But user interfaces are more than that. More stuff about what a user interface is. For this talk, you can debate all sorts of stuff, but for this talk, the UI is that point where people interact with things. Right? That's a user interface. So I was talking to somebody earlier. If you have a soda can, right, the little pull tab, that's a user interface. Right? Make sense? If you're, the pop top on your bottle, any of these kind of things. And UIs in general have two main things. One is to help you get something done, right? Access the soda, or get the data from the Google Books API, or pull the data from the giant database you've got to get information about the business, so that they can produce reports, so that somebody can decide whether or not they should close a place in some other city. And the other thing is to let people know what's going on, so that they can decide what they want to do next. Right? So if you're doing something on the web and it's going to take a while, you might put up one of those little loading things so people know that, oh, it's not dead, it's just doing something else, and I should wait for a bit. And if it stays there for too long, then they can get upset with you and kill it, or try submitting the thing again. But this is a user interface. This is a glass door with a handle on either side. Okay? So let me ask you a question. If you approach that door, should you push it or pull it? Pull? Who says pull? Okay, we've got some. Who says push? Who's not willing to commit? Okay. So if you look at the way the door is built, the handle there, you're going to grab it like this, right? And you want to pull. This is a pull door. Based on the way it looks. You won't know until you actually try, and I tell you this because I have seen, and actually I work in an office where it has handles very similar to this, and it's not. It's the door like the one out here for the room. One side you push, one side you pull. And the first time somebody goes to use that door from the wrong side, they realize, it's not going to open, so I got to push the door when I think I should pull it. This is a little bit of a bad UI. All right? And the thing is that even if you've learned that sometimes you have to push instead of pull, I've run into this myself, and I've seen other people do it, where if you're involved in doing something, a conversation with somebody about a problem, or you're thinking about something, anything that's got your attention, when you walk up to the door, you pull it again. And then you go, oh yeah, and you have to push it. Right? So user interfaces can be problematic. And so people do different things. This is a door, same kind of thing, but you see that horizontal piece on the other side? That's telling you need to push, right? Because if you're gonna, when you reach down for this, you're not gonna grab it, and you can, but it's more common to push. In fact, the crash doors on the crash bars on the door back here were designed specifically for that purpose. There was a tragedy in Britain. People got crushed trying to exit a building because the doors, first of all, pulled inward, and second of all, they couldn't turn the locks and stuff. So these things are designed so that if there's a whole crush of bodies trying to leave this room fast because there's an emergency, and you get shoved against the door, you will push that bar, and it will open. You can't not open the door from this side. So this same kind of a thing. The affordance this has, and affordance is something that gives you a hint as to what you're supposed to do, and we see these in user interfaces, GUIs, gives you the idea that this way you pull and this way you push, right? So what about this one? Yeah. Do you push? Do you pull? Do you just stand there and wave? This one is, looking at the hinges, you can tell it swings both ways. Right? So you can push or pull, it doesn't matter, the door doesn't care. And this is probably one of the best ways you can design an interface. Right? You can't not open this door properly. If you want to pull it, it lets you pull it. If you want to push it, you can pull it. pull this way, right? So, and one of the reasons I've been doing this example with the doors is because I want you to get the idea. It's not just GUIs that we can learn from, and the principles are all around us, right? Good user interface principles are all over the place. User interface stuff goes to the topic of user experience, which you can read about or not. Basically, it's about how you feel when you're using something, right? So if you're using a piece of software you really enjoy, right? It does what you need. It gets out of your way when you don't want it. It's very simple and easy to use, very intuitive. And so it's all about usefulness, right? Ease of use and efficiency. How well does this software work with you? And that's why some people really love Eclipse, and some people love JetBrains, and some people love NetBeans, and some people love VI, right? It's how it works for you. So the user experience of your API will depend upon who's using it and when and why. And it can and will change over time, right? So if you start off using a new tool, you may not like it at first because it doesn't work the way you're used to. Your fingers are trying to put the wrong shortcut key, or you switched from Mac to PC, and the close is in the wrong place, and all that sort of stuff. But after a while, you get attuned to it, and then it's still usable and it's good. I had a wonderful experience recently. Had a headache, and I went to go take some Advil, and they came in a foil packet like this. And I went, oh, foil packets have a little tear spot, right? So I'm looking for the tear spot, and I couldn't find one. What I found was this thing down here. That's actually literally a slit. And I'm like, oh, how do I use that? That just doesn't work. But I looked at the other side, and it's got this kind of thing there which says I should be able to do it, and it just wouldn't work. And so I took a pair of scissors and cut it open, right? Then I found out what you're supposed to do is fold that corner over, and the slit becomes a tear spot, and you can rip it. But the good thing about it is, unless you folded it, it won't tear. So when you're shipping things, or if you're packing and you're moving it around, it won't open accidentally. So it's actually a safety thing. And now that I know about it, it's a really good thing. I really like it. But when I had the headache, okay, I wasn't thinking about that. I was thinking, right, I need to get out of the room. I need to, right, pull, push, I don't care. Just let me get the stuff. So this is what I'm saying. The user interface didn't change any, but my user experience with it was completely different because my mental process was different, right? So when we're designing things, you've got to think about, like, what are the people doing? What are they trying to do? How critical is it? You know, what's just all of these sorts of things. And you learn over time. So speaking of learning over time, I've used this example several times talking here about user interface, user experience, and it has a bearing on this because as you design your APIs, you need to design for change, right? If you've gotten coffee here, you've noticed a few things. They have the coffee cups here, they've got lids over here, there's the coffee, there's all the stuff you're going to put into it, right? So you see the problem, right? The lids. So you get the coffee, and you can either take a lid with you and kind of hold it in one hand while you're trying to fill the thing and twist, turn, or you can leave it and then come back around and try and, excuse me, I just need to get in here and get a lid, right? Well, I don't know if it's because they've heard me or if somebody else said something, but they started doing this. They started putting lids at the end too. So the people who are used to it can get one because they already know how they're going to do it, or tuck it in the pocket, you know, whatever. And the people who haven't and haven't done it before, they can still pick up a lid and everything is cool. You don't have to cut in line and just all that stuff. So design for change, right? Think about the future. And so with the Google APIs, right, the V1 is in there so that if they have a V2, the old people can still use V1. The new people who want to do the cooler stuff can use V2. And you can put that into your APIs as well. So you're an API designer. Okay. So the whole reason I talked about the user interfaces and stuff was to come up with this idea, which is that user interface, user experience principles can help you design better APIs. So things like this. Names have power. When you're designing classes, right, first thing is the class name. Classes are things, right? And if you can't come up with a good name for a class, it probably means that your class is poorly conceived, right? If you have something that's a manager or utility or a MISC or a helper or something like that, it probably means that the class is doing more than one thing. And it may be doing more than one thing for more than one class that it's supporting, right? So when somebody goes to read the name of the class, they should know exactly what they're getting, right? So a date class should hold a date, right? But if you have date manager, What does that mean? Someone who helps you like manage your dates, or it's too fuzzy. Method names are the same thing. Your method names should tell you exactly what's going to happen. Somebody reads that, they should know. And if the behavior of the method changes over time, then you should change the name of the method to make it match, or figure out why you're doing something different here and go back to what it was. Right? Something's out of sync. Right? So I'm working on some legacy code. I've got a method called, and it displays a table of data on the screen. And there's a method called select cell. And I thought, oh, okay, so this is what actually highlights the cell for me. No, when you click on the cell and it calls this method, what it does is it takes the contents and changes it from an X to an O, and from an O to a space, and a space to an X. That's what a select cell does. Sure, of course. No, right? Right. I used to think that, people talk about self-documenting code. Code doesn't lie. Code lies. Not intentionally, but it does, right? Because over time, things change. So we need to have good names. Method names, class names, constants, all of these things are important. When you're doing user interface, right? The door with the pulling and pushing, right? You can't misuse that door if you're trying to use it as a door, right? Because if you want to push it, you can. If you want to pull it, you can. The way this relates to code is, let's suppose you've got a method that takes two parameters, right? And they're both ints, like assert true. Okay, assert true. I give it two values. Is it expected and actual? Is it actual or expected? Which way does it go? Who knows? Anybody?
Expected actual.
Expected and actual. Okay. Is that for JUnit? For testng? For Jasmine? For is it consistent across all of them?
No, not necessarily.
Probably not, right? And that's another issue is standards, right? So I think I mentioned so under minimizing mental friction is how hard do you have to think to get it right, right? And things that can help with this is leveraging your pre-existing knowledge. If you're working in Java, you know certain things like Java beans, right? You have properties, you have a getter, you have a setter, and you might have an is if it's a Boolean, right? So if you create something that's supposed to be a Java bean, but you want to do something similar, but you want to do it a little bit different because you got a better idea, that means that all the tools that understand Java beans won't understand your cool new Java bean, right? Which means somebody else has to take the time to understand how this works. It increases the mental friction. It's a little bit harder to use your code. It's a little bit harder to use your API. But if you follow the standards, if you do things the way that everything else does, whether it's awesome or workable, right, it means that people can use your APIs easier, which makes it easier for them to use it correctly and not have to think about it, right? Because now you've got Java doc for all your code, right? I don't see any hands. Okay. Mine's only up halfway. But the Java doc, right? All your IDEs now, all the cool IDEs will tell you when you're typing in a method what the parameters are. And it'll tell you, is it supposed to be the expected or the actual or things like that. But it shows you from the Java docs, right? So in your Java doc, if your parameter names are N1, N2, N3, that doesn't help. But if your parameter names are today, tomorrow, next week, oh, okay, now I've got a better clue as to how I can use this. So this is why the tools, the Java doc stuff, and the sample code is important, right? Because when people are using your code, the samples you give them are the samples that they are going to cut and paste and stick in and make part of their code, right? One of the problems that Sun had early on with some of the JEE stuff, before it became J2E, was the samples they wrote for EJBs worked well to teach people how to use EJBs. But if you copied that code and put it into your code and started using it, it wasn't particularly efficient. It also wasn't particularly well encapsulated. But because it was there, that was the template. That's, before we had all the nice copy-paste stuff that we could use, we would read from books and type in, okay, that's how that works. Cool, I don't have to study this and learn it and figure it all out because I've got working code I can use. Your sample code will become the same thing. So if there's problems with it, people will use your sample as their production code and then call you up and say, this stuff doesn't work, right? So make sure that anything you publish to go with your code is something that you wouldn't mind somebody using in a production system. The principle of least surprise. A method called select cell should not toggle the value of the cell, right? It's not what you would expect it to do. I think Josh Block has a good talk on designing APIs. He's not talking about user interfaces with them, so I'm not stealing from his stuff here. And I suggest you go watch it. I've got the URL at the end of this. And the example he gives is thread interrupted. Right? There's a test method for thread to see if it's been interrupted. The problem with this is it also clears the flag that says the thread was interrupted. So if you check it, and it says it was interrupted, and you say, really? And if you check it again, it says, no, I'm good. Right? So this is one of those surprises you wouldn't expect, and it can cause problems. So you know, if you push a button that says up, you don't expect to go down. Those kind of things. Make sure, and Apple had this issue with some of their UI stuff, right? On the scroll bars. If you move the mouse over to it and you do the gesture to go down, and it would slide up, and you, what? Or you do the other way and it goes this way, and people freaked out because it's not right. They were surprised. It wasn't. So they had a toggle in there so you could turn it the other way if that's what you wanted, right? And that works too. You can adjust for what people expect. And the last thing is the principle of grouping and chunking. And this one it's a little complex, so we'll go into it in just a sec. But I wanted to mention, who can read that in the back? Anybody? No. Okay. This button I'm wearing right here. About 30 years ago, I found this at a science fiction convention and knew I had to have it. And it's something that will serve you well, right? Because if you do this, your code will be clean, it will be understandable, right? The slides will be available on the, but clean, understandable, you'll have tests, life will be good, and when you go back to look at your code 6 months from now, you'll be able to understand what it's supposed to do. But grouping and chunking, to get back to things, is very important because if you have a method that takes all these parameters, right, it's going to be a bear for somebody to figure out how to use it. But if you were doing something to create an account, you might have all these parameters. So the first thing you do when you take a look at this is you mentally, you want to start trying to put things together. Oh, yeah. What's worse is the types are all ints and strings, right? So if you've got a parameter list that's int strings, how do you know which is which? I hate those, right? The human brain, they say, deals with about 7 plus or minus 2 items, right? So, but I need all this for my stuff, so what am I going to do? Well, the first thing to do is you want to group things that are kind of related, right? So I color-coded these, right? So first name and last name, that makes sense, right? Street number, city, state, street name, zip code, apartment number, extension, those all sound like they're related. And then area code, subscriber number, exchange code, well, I'm not sure about that, but that's what's left. So that's part of grouping, right? Because we're starting to put them together, and then you kind of put them together because the human brain works this way. Things that are close together are related in our heads, right? Whether they are or not. If they're next to each other, they're probably related. And you can start figuring out, okay, yeah, this looks like something I recognize. And we change the order a little bit, and yeah, that's an address, right? Area code, exchange code, subscriber, that's actually a phone number, right? And of course, first name, last name is a person name. So now instead of 16 items, I've got 3 things that I need to deal with. I can deal with 3 things, right? As a developer, in fact, put them in an order, and it's like, oh yeah, that makes sense. You need all that stuff in order to create an account for something, right? And there's my classes right there. Person name, address, and phone number, right? So now when I'm doing this, yeah, person name, I have 2 strings, but it's pretty easy to tell first, last, I think I know what those are, right? Address, street number, street name, apartment number, city, state, zip. Yeah, I got that, right? But when you start off with this whole mess, there's so much mental friction, so much clutter, it's hard to figure out what the heck is going on. And it's very easy to make mistakes. So ordering, grouping. So that's the grouping and chunking stuff. And I didn't say this as we were going through. Oh, that's because I didn't color code this one. Grouping is putting similar things together. Chunking is breaking those things apart. So at this point, right, these are separate chunks. Those are related, these are related, those are related. Those are the chunks. Okay. Okay, so we've got the first out of the way, and I think I've got you convinced that APIs are user interfaces, and that you can use some of the user interface principles to improve your APIs. Is that making sense? Yes? Cool. So how do you do this? Okay, well, you want to think like your user, in this case like an API user. Who's going to use it? What do they want to do? Right? Because that's going to determine what your methods are, like in a class. If I'm creating an account, what do I need to do? Well, okay, so I got to create an instance of the class or not. I may just want to have a static method to create an account, right? Or maybe a static method to create a person and then an address and a phone number, and have those be separate methods, and then at the end of that call create account, and it's all set. So if you're using the what do they call it, humane style interfaces, some people call them train wrecks, right? So it's like account dot create person, person name, create address, create and execute, right? So what you do is you sit down and you say, well, if this thing existed, how would I want to use it, right? Before you try and define the API, write the code that someone would write to use this thing, right? So I've got a class, I want to create an account, so I'm going to start writing some code and use it the way I want to, and say, well, I don't want to pass in 16 parameters. That's crazy. How can I make it easier? Do the chunking and grouping and figure it out. So now I'm passing in 3 parameters. I'm happy with that. It's cool. Or not, right? You may have something where you need to pass in a lot of context because you're tracking transactions. You need to know which method was called on which server, and so that's going to go into your logging stuff. So if you pass in a context object, you don't even care what's in there because the logging piece is going to take care of that. But it's got the transaction ID, it's got the time, the date, which server name you're running on, all those sorts of things, and they go into it. So you can say, well, yeah, okay, it's magic. I don't care how the context gets built or what's in it, but that's what's going to have all the information I need. Right? So you write it as if the code ever existed, and then start looking for patterns. You'll see as you start writing this stuff, some things seem kind of clunky, right? It's not fun to use this API. And look at it and kind of think to yourself, what is it I'm doing that I don't want to do here, right? Maybe there's something the API can do for you. So, an example, Java 8's come out, so the date class is really kind of unfair to pick on, I guess. But using the Java date class, a simple example, right? So I want to create an API for Valentine's Day. Not bad, right? It's a Boolean. I don't need to put in ints for, I could put an int for the day and the month and the year, but I don't need to do that. I can use a date, right? And then all I have to do is say, if it's February 14th, right? So date.month is equal to 2, and the day is the 14th, it will return true, right? Seems easy? Decent API for, yeah, it doesn't work, right? You're smiling, why doesn't it work?
It's mutable, so it's
Pardon?
It's mutable. So
it's mutable?
you check and then it changes from different threads. It doesn't.
Possible. But even without that, it still won't work. If I do a JUnit test and I call this with a date that's been set to February 14th, it fails.
One is
you know what?
based, one is
yeah,
based.
Date is 0 based. Right? The months go from 0 to 11. That's one. There's another problem, right? Day is 0 based. Day is not get day of the month, get day of the week, right? Who'd have thunk it? Not me. But it's true. So if you change it and do it right, you use get date. Okay. Principle of least surprise. Date.getDate should return this. Right? But no, it returns the day of the month. Right? So what you're supposed to do, okay, now we talked about changing your APIs and putting a version number into it and all. Sun had promised early on, and I don't know if you guys were around for that, that they would not break code. Right? So because date existed and was what it was, they couldn't fix it properly. So they created a calendar class, right? And calendar's a bad name. We talked about the importance of names, right? Calendar for a date, okay? The calendar is a year. It has 12 months. Calendar.add 2 weeks doesn't make sense. I can't make a year longer that way, right? But that's what you're supposed to do. So you look at the code and you're like, what? So JodaTime had the benefit and did some thinking and went, look, get month of year is 2, right? It works. Get day of month. Get day, I don't know what get day does, but get day of month definitely returns the 14th in this. So they also did this. They've got a date time constant for February. So I can say get day of month equals February. I don't have to have numbers. I don't care what the 2, 3, 1, it's February. That's what I want to know, right? So when somebody's reading the code, right, date get month of year equals constant February, you can tell, how do you phrase that? It's obvious that that's got to be correct, right? So when you write your code, if it fails, there's something really wrong, right? Because maybe somebody modified the date on you. So recommendations. Write lots of client code. In Josh Block's talk, he recommends writing 3 different clients, trying to do 3 different things. Because if you write one, and then you publish your API, it's probably not going to work. If you write 2, it may work for most people. So if you do it 3 different times, 3 different ways, it should work for everybody. And at the time he was working for Google, and he's, Josh Block's the author of Effective Java. He's got a lot of experience. I certainly go with his recommendation. This is another fun piece with date, right? How many times have you seen this code? I've got a SQL date. I want to make one out of my Java util date because I can't use it with SQL for whatever reason. But I can't just pass in the date I have to call get time. Really? I can understand. What it does is it lets them decouple the SQL package from the util package. But if you're using Java, you're probably using something in util. And so it really makes sense to me that you would have that. If you don't have a utility class in your code that does this, write it so you don't have to see that code in your production stuff. Because you see it over and over again, it turns into noise, you stop noticing it, and if somebody doesn't make that call properly, you will not see it because your eyes glaze over because you've seen that so many times, right? Date, new, SQL date, new date, and you just miss it, just like pulling on the glass door that is only going one way, right? We have patterns in our head. We see the patterns, they become unconscious. When we're driving, we don't think about, oh, there's a car ahead of me, so I need to change lanes, or those sorts of things. Coding happens the same way, especially if you've been working long hours and you're tired, right? You look at the code and it works, and everything is good, and then when you run your unit test, it fails, and you go, what? And you look at it and go, oh yeah, right? Everybody have that experience before? Right? So our brains don't always work the best for us, but they do a really good job overall. So anytime you can take code like this and put it into your API so the person doesn't have to do it, right? And JodaTime, by the way. So if you can do that and take that work out, that's one less thing that the user can make a mistake with, which makes your API easier to use, easier to understand, and more popular, and so it'll go up on the GitHub stuff. So final takeaways, you are an API designer, put it on your resume. They are user interfaces, think about your users, and look around. There are all these wonderful books on user interface, user experience. There's lots of articles on the web. And write your code as if you. So this is a book, The Design of Everyday Things by Don Norman. Excellent book on things. Fun part is, so this is talking about design and how to do things right and how people get confused. This is the masochist teapot, by the way, right? So if you're going to pour it. So the fun part is this book was originally called The Psychology of Everyday Things, and it didn't sell well because they stuck it in the psychology section of the bookstores. And the psychologists went, what the hell? And the designers were going, I don't know what you're talking about. There's no books by Don Norman here. Right? So he had to change the title of the book. Another book, Emotional Design, also by Don Norman, wonderful thing. That gizmo is a juicer. And they have a gold-plated version of it because it looks like a rocket ship, right? Is that cool? There's a gold-plated version of it that people buy, but they can't use it because the juice will erode the gold. Right? It's there, but people buy it because it looks so cool, right? So, if you do a good design, you can sell things even that people won't use. But this is all about why we love or hate everyday things. And it's another thing to help you think about what you're doing and how to make people love your stuff. Jaroslav Tulach, I hope I got his name right, has a book. This is several years old, but it's an excellent book on API design. He's the team lead for the NetBeans group, and they have done lots and lots of APIs. He's learned a lot about how to do it right, how to do it with teams, how to make it work, and he shares all this stuff here. Effective UI is another good book. It's mostly about the computer user interfaces, but lots of good stuff. Once again, the slides are available. You don't have to write this stuff down. Josh Block's stuff, it's about an hour long. This is a Google talk. And of course, Effective Java. If you don't have it, get it, read it, learn it. And that's it. Any questions? Any kind of... Yes. So, no questions?
Where can I get one of those buttons?
I got it 30 years ago at a con. I don't know. You can there are button makers. You can probably go to Cafe Press and maybe get them to do anything and make some money off of it. As far as I know, it's not copyrighted. So yeah. So thank you for your time.